Hello. Hello. Today we will understand how TCP works. TCP stands for Transmission Control Protocol. It is at level 4 in the OSI model, which I discussed previously. The main aim of TCP is to provide a reliable data delivery between the two devices. Here, for example, let's consider client and server as the two devices. Client can be a browser and server can be actual API server. Okay. Let us take a simple example of client server communication. A simple client server is server sending and receiving of data happens at the TCP. This TCP also, for example, we have another protocol UDP, but mostly TCP is used in order to send the data reliably. Okay. So remember at we have application layer in the OSI model. The application layer works at layer 7, uh, layer 7, but at the back it uses the TCP, which is at layer 4 to send the data. TCP is the actual one that is sending the data and receiving the data at once. Okay, so the main aim of TCP is to provide a reliable data delivery and ensure data arrives in the correct order. Okay. Now we'll understand there is a three-way handshake in order to establish a communication between two devices. So how TCP works in that way. So in order to establish a connection between two devices, we need to complete a TCP three-way handshake. What is three-way handshake? So the first thing is suppose you want to send the data to suppose you want to make a API call from a browser to the server. So what happens in the background is so first a connection needs to be established. So for that client sends a sync command. Okay. Then the server receives this sync and it acknowledges it with SYNAC. Okay. So step one is client sending sync. Step two is server acknowledging that and sending a response of SYNAC. Once client has received a SYNAC from that particular server, then client responds back to acknowledge. That means he has also acknowledged what the server has said. After this three-way handshake, then the connection between the client and server is established. Okay. Uh, so also remember one more thing that whenever there is an HTTP call that is using a TCP in the background, the HTTP by default uses a TCP. You can convert or write a specific code to use a UDP also, but default it has a TCP. Okay. And wherever you make an HTTP call, make sure to remember that there is a TCP handshake happening at the background, and then only the connection is established. Okay. Next is why to use TCP. Okay, in TCP, the data is getting divided into segments. Okay, you have a large JSON of a post request where username and password. It is not sent directly. It is divided in the form of segments. Each segment has a sequence number. Okay, why we need this sequence number? Because the data needs to be delivered in a reliable manner, such that if client starts sending data in the form of segments, say segment 1, 2, 3, because it has a sequence number and it reaches the server, say S1, S2, S3. These are generic, the numbers are not like 1, 2, 3, they can be anything. So in this example, we are treating sequence number as 1, 2, 3 only. So S1, S2, S3. Okay, so client has sent data from S1, S2, S3, S4, S5, S6, but the server received till S3. So what server will send back to the client saying we have received, it will send ACK to ACK of S3 only. That means that S1, S2, S3 is received, but post that client server has not received any data. So it's the job of the client or the TCP at the client to retransmit the data. So it will again send the segment from S4, S5, S6. So this ensures the data is retransmitted in case of any loss. So lost packets are retransmitted. So this is a job. This is very much important and very much handled in TCP. Next, once the communication is completed, for example, client has requested for a login and server has response back with the login with the access token and everything. Now there is no further communication. So client has to close. So client there is the TCP connection needs to get closed. If you're using HTTP1, it keeps the connection live. So it uses keep alive. So the connection is open for a longer time. But now the client there is no further communication. So it's the job of TCP to close the connection. So for that we have a four-way handshake, four-way tear down. We call it tear down so that the connection can be closed. So first client will send a pin to the server. Server will send an acknowledge getting that we have received a pin from this particular kind Then server will again send a pin from its side that okay, I am ready to finish the connection or close the connection. Then step 4 is client sends that okay, I have received your pin, I am closing the connection. And finally the connection is closed. So this is how a tear down happens when you want to close a connection. Okay, in the back. This happens in the background. You won't be able to see if you're making any API call in the network or in the Chrome or in the browser. So you won't be able to see the things that happening at the OS level. Okay. So summary is TCP some very important points to consider over here. TCP ensures reliable communication using connection setup, acknowledgement of the data that is received by the server, and retransmitting it by the client when there is a data loss. This is why it is used in applications like web browsing and emails and all. Also, it is very important to understand that whenever you make an API call, for backend engineer, it is very important. Like whenever you decide to make an API call to the network to fetch the data, keep in mind that TCP three-way handshake is happening in order to establish a connection, and four-way teardown is happening in order to close the connection. So, if possible, try to avoid it because although it's very fast, but still, if you have a high, if you need low latency and large user database, large set of users are continuously accessing your servers, and so in that case, you can, if possible, you can avoid this. Yeah, thank you.